Thank you for coming. It's always a huge privilege to talk to you all, at the group that I help run, so it's awesome to be here. Hopefully you recognise me as one of the people on the initial slides, and if we haven't spoken before, come say hi tonight. I'd love to speak to you. I'm an Android developer, sort of by day. I work remotely in Bristol, and this talk is about why I love Charles. And you might be thinking, how can the Prince of Wales help with, mobile app and API debugging? And you're right to think that, because it's got nothing to do with this. I just like having pictures in. This is a short talk really about Charles Proxy. And for those kind of unfamiliar with what this is, Charles Proxy is just an app that you run on your development machine, and it sits between your mobile app, and you can intercept and manipulate the request and response. So this is kind of like the typical kind of setup, and this is for like API requests or any kind of request that your network request that your the app would make. You might be thinking, why? Why is this useful? So it's for like debugging, testing. You can simulate slower connections, error states. Hard to create like server-side scenarios, like an account needs to be in a certain state to produce a certain error. You don't have to sort of go through the setup of doing that. You can just get Charles to sort of respond with an error that you've crafted. And I'll sort of talk through a bit of this examples. But like at Help Scout, where I've used this for our Android app, I spotted a bug in our attachment uploading code where we were accidentally including the body of the attachment, the content of the attachment file twice. So like a 3 meg file was being a 6 meg upload, and I think we ended up like hitting our, the bug was raised because we hit our like attachment limit on files that were lower, and that's what kind of instigated me looking at it in Charles. I found like missing request parameters when I'm looking at comparing like the iPhone app and the Android app and trying to work out why this thing isn't working on the Android app. And it was very easy, without having to delve into the code of the iOS app, I was able to easily see, oh, they're just passing that ID and we weren't passing that. Also, I've identified tons of places, actually not tons, that sounds bad, but 1 or 2 places where our SDK and our app could be more streamlined. We're making too many requests and updating things which don't need to be updating every sort of session. So let me just talk about a bit about Charles. So it's an app. It runs on all the platforms. Even there's an iOS app for it as well, so you can proxy on your iOS device. So if you're tethering, something like that. I've not tested this, but I thought it's worth mentioning. The other thing I should mention is it's not free. We're probably used to lots of free tools. This is like, it's around £39, so £39 for a single license or $400 for a site license. But I think, like for me personally, it's one of those tools that I use day in, day out, and definitely worth the money. But I thought I'd mention that up front. There are, of course, alternatives. Android Studio now has a network profiler built into it. You can use Chrome DevTools to do a similar thing, to inspect the network traffic using Stetho, which is a plugin library from Facebook. Pony Debugger for iOS does something similar. Chuck is another Android library that will kind of throw up your networking stuff to a sort of persistent notification. And also there's a bunch of other things like Man-in-the-Middle Proxy, Fiddler. They're tons. So I'm not saying Charles is the best, it's just the one that the presentation's on. And actually, I'd be keen to hear if there's other tools that people use that do stuff that Charles doesn't do. I'd be keen to hear that after the talk. I thought just a quick show what this looks like in Android Studio, because this is a fairly new feature. You can now view, you can profile your app, which you've been able to do for a while, but now with the network profiler, you can sort of see the content of requests and the timeline stuff. Something that actually this does that Charles doesn't do is it gives you the sort of what radio frequency state, not radio frequency state, the radio power state, which is ideal if you're debugging your app to try and make it more power efficient. So that's quite a cool thing. That's only within that. But this is what Charles looks like. What we have here is a bunch of requests that the Help Get Mobile app does when you sort of refresh a session. It goes and downloads a bunch of requests, gets the user information, uploads a token, and gets a bunch of other stuff just to show you what you can do. So you can view all the headers, the content of the requests. You get it nicely color coded with JSON. You can also get the JSON in a kind of like object tree, so you can just kind of focus in on what the parameters and the response stuff that you're interested in. And you have a bunch of things like the size and the duration, stuff like that. And now I'm just going to talk about some of the stuff you can do in it. So viewing it is all, that's great, and a lot of the tools offer viewing the stuff. But where the real power comes is when you start manipulating those requests. So you can set breakpoints, on your API calls, but just in the same way as you'd set a breakpoint in your IDE. When you're debugging, you can debug, calls to APIs, and that's where it gets interesting, because then you can start editing the requests. So you can quite very easily turn a 200 response, a success response, into a 404, and see how your app sort of handles that. And some of this stuff you could do, with mock web servers and unit and integration tests. But I think this is a lot better. Well, it's just a different way of approaching it, because you have the app on a real device, connecting to the real server, and you can sort of manipulate things. So where I've used this the most is simulating errors. Sometimes they're harder to. You get the happy path when you're doing your testing. When you're developer testing your own sort of work, this is a good way of testing all your error handling code. And also doing things to your app where stuff that the API is guaranteed to provide. This will never be null. What happens when it is null? Because it always happens, and typically iOS was always better at handling this with Objective-C, because if it was null, it was just fine. Whereas in Java, it would just crash. So it's good. It's a good way of sort of provoking those occurrences in your app. Another thing you can do is rewrite rules. So this is kind of like the previous slide, kind of like editing stuff, but this is more an automated way of doing it. So here, the app, the Help Get app has the API has this thing. So every API request, it checks to see if the app is on the latest version, and if it's not, we have a force update sort of procedure. So sometimes we need to force people to upgrade to the latest version of the app for security reasons or significant bugs. So I wanted to test, and this can happen at any point, any API call. So I wrote this this rewrite rule to change any request to our error 400 that the app needs to be upgraded. It was just a lot easier just to turn on and off this rewrite rule at any point during the app's usage, to make sure that the handling is sound. You can also map particular requests to local files that you have. So if you want to serve a particular file, again, you're trying to create those scenarios where so you don't involve the server setup. So I've used this most recently in the last couple of days to simulate where a user, their payment plan has expired, and I want to make sure the app handles that in the appropriate way. The error response to the server has a couple of different parameters in there we need to parse, and the output on the app is slightly different each time. So rather than having to go for the hassle of configuring a user account with payment, with an expired payment card, I can just very easily create a mapping, and in that local path I just set it to a JSON file, which is the error response. So it's super quick for stuff like that. You can of course as well do throttling. So this is like simulating a poor connection. This is really useful. So like the Help Get app was something I inherited, and so it wasn't something I'd been involved from the start, and it was really interesting. Enabling throttling was one of the first things I did, and I noticed how we hadn't got loading states for a lot of screens. So you would send an email, and it would just rely on the fact that would be a quick thing, which it is over 4G and Wi-Fi, but not when you have throttling or on a a 2 or a 3G connection, and so it was quite useful to sort of spot some of those things. And it's something that it's easy to sort of, it's another test that, as your tester or as your developer testing your app, it's worth doing. So I thought that's kind of like the features. I thought to talk a little bit about the setup in case anyone's sort of new to this, and then sort of talk through some of the gotchas. So you can, I probably didn't make it enough clear, but this is, you can test any mobile apps, so this is the configure how you'd set up your test Android or your test iPhone device. So you go into your Wi-Fi settings, the advanced tab or the advanced section, and then just set up your proxy server. So this is running this, you use the laser, it doesn't work. Room at all.
In the future if you don't have lasers.
Yes, it does work. Okay, everyone watch this. So this is like the IP address of my computer at home that's running Charles, and 8888 is the default port. So this is 2 devices I have connecting to that. So it's simple as that. And then once you connect, Charles will prompt you to say, oh, do you want to start proxying requests from this client? But you might be wondering, what about, some of you may have heard of TLS, SSL, and isn't that meant to stop people from intercepting communications and being able to read them? And you'd be exactly right. So this is an example of what it looks like if I intercept some requests to a Google service on one of my devices. It's completely encrypted. And so for this, we need to get our inner hacker out, and we basically have to do a man-in-the-middle attack on our our development devices that we're testing with. It might sound a bit scary if you've not done that before, but it's pretty simple to do. And I probably would recommend you do this on you're doing this on for your apps, and you're doing this on your test devices. You don't necessarily want to set this up on your on your personal device. But it's definitely this area, like setting up SSL proxying with Charles, is definitely like the hardest bit. Once that's done, it's all plain sailing from there. And sort of as a nod to this, there's a ton of help on this, and there's a load of stuff which it'll do for you. So if you want to set this up with iOS simulators, it's a one-click thing to do it, and there's a bunch of other stuff. It's really quite straightforward to do, even if you don't understand how SSL works. It's not a kind of prerequisite. The basic thing you need to do is you set your device, like we showed in the previous screen, you talk to Charles. You enable that. You say yes, allow connections, and then you need to go to this special URL, and this will prompt you to install the root certificate. And this is what basically allows you to do the man-in-the-middle attack effectively. And then for each request you want to enable SSL proxying. So you don't want to do this for everything, because some things won't work. So if you do this and you want to try and see what Google are sending, like Gmail is sending to the Google servers, or Twitter are sending, you'll notice it doesn't work and won't connect because they have additional protections like SSL pinning and other stuff. You really just want to enable this for your own apps. As you can see there, a bunch of things related to Help Scout. So just to quickly recap that, you connect your device to your to your laptop or whatever running Charles. You install the root certificate. You can visiting that special URL. It will prompt you to install it. You can actually provide your own root certificate. That's particularly useful if you have a bunch of testing devices in a co-located company where you're swapping devices all the time. That way you don't have to sort of mess around with the config. You can just have one SSL root installed on all of them. You enable it on a per domain basis, and that's it. You're good to go. There's a couple of side notes and gotchas for Android. If your device is running Android 7 and above, you're going to need to have this, include this config in your app. And this is like something in Android 7, because users were getting duped into, so what you're installing there is a root certificate to allow you to intercept SSL communication. And what Google found was people were just getting duped into doing this in the wild, and then just they were getting their secure connections intercepted. So what they did with Android 7, they made it so by default anything the user installs certificate-wise isn't trusted unless the application overrides that. You don't have to sort of worry too much about the details, but basically this is the config you need in your app, and this is surrounded in this debug overrides, which is really essential because then that means this is only on your debug version. There's no chance of this config getting to the Play Store because you can't upload APKs to the Play Store that are debugging. So it's quite a safe way of doing it for debugging only, and you don't have to worry. If you didn't use this and came up with some other way of doing it, like an if-else statement or a flavor or something, there's more of a danger of. So I'm thinking like a build config field which you had as debug or allow trust certificates. This is a sort of safe way of doing it. And the other kind of gotcha, if you're running Android 9 and you're using clear text on anything, that's blocked by default on Android 9, and so you'll need similar configuration to this. So I came across this recently when I was running. So I sometimes run our API server on my local machine when I'm doing changes and playing around with that, and I found it didn't work, and that's because clear text is blocked. I haven't got an SSL certificate installed on my local machine that's for that connection because it's on my secure network at home. So in theory, I should be all fine. If you're connecting to like a staging server or development server, which is like on the network on the internet, that isn't secure, you'd need to put this in as well. But I'd probably recommend better to get a free Let's Encrypt certificate for that, and so start using SSL rather than put this kind of exception in. But that's a couple of side notes for Android. That's where I spent most of my time. There's a bunch of other stuff it can do. You can run it headlessly, so there's a web interface. There's a host proxy for the OS as well. That can be really useful, or just interesting to see all the amount of analytics and crap that various different Mac apps or whatever your apps running on your system, what they send back home. There's also like basic load testing, which I've used to sort of trigger certain server events on a particular error message. I wasn't sure how it's formatted. Triggered that by this advanced repeat. Some of the sort of like sort of gotchas, I'd say, or the tips. It can be really quite noisy. When you've got, especially if you've got a device with lots of apps, there's lots of stuff connecting. So definitely make use of focus. There's a way you can right click and focus, and it will just show that domain, and everything else will be like in a separate little expandable list. That's a really good way of we can focus. So for me, I focus primarily on our mobile API because that's where most of the stuff's going. You can also filter, like use regex if you want, or just start typing this, the start of the endpoint that you're connecting to, and it will just filter by those requests. And also, I'm quite disciplined at using ignores. So if I see something from like a Gmail or from Samsung apps or something like that, which I never need to care about, it's just noise, I just right click and add that to the ignores list, and that keeps the noise down. When you're sharing with your team, you can export a bunch of the rules that you use. So if you set up remote or local mappings, rewrite rules, you can share all those. You can share sessions as well. So if you have a bunch of requests that you want to share with someone else, you can do that, and that can get loaded into trials. You can, if you want to share sort of further afield, maybe someone hasn't got the trials installed, you can quite easily create a GitHub gist of that. And actually, the one I found the most useful when dealing with other teams, particularly API developers, if you can give them a curl of the request you were trying, that is like gold dust. That saves. If you're reporting a bug on the API and you can give them a curl, they can see exactly what you were sending. At that instance in time, they can see what the head is, and the amount of times that stuff's been solved like really quickly, because they'll go, "Well, you're not sending header such and such," and we're like, "Well, you never said." And that kind of thing comes out, and you know, you could spend ages going back and forth, but you've got the code, it's like there in sort of black and white. If, like me, you have multiple test devices and you're connecting to the same laptop, it can be difficult sometimes to sort of, there's quite a lot of noise, and also you're filtering and you're focusing, but they're all going to your API. But what you can do is you can show the client IP column, and then you can group by client IP. So that's the IP address of your phone or the device it's connecting. That can be quite useful. Another thing that's worth bearing in mind, that if you're doing lots of manual manipulation and editing of requests and responses, you'll probably need to increase your connection and read-write timeouts when you set up. So if you're using an Android, you're probably using OK HTTP or a URL connection if you're old school. So that's something to bear in mind. So like when I did a demo of this talk, I tried to do a demo of manipulating a request. I was sort of too slow in terms of editing the request to see it happen, and then the app just registered a request timeout, and so it was a total fail of a demo. But yeah, it was a good. It highlighted to me. Oh, we need to in debug. We need to increase our timeouts from like 15 seconds to, I think, like we changed it to like 2.5 minutes or something, for debug only. If you're doing that. The other thing, I kind of touched on it a little bit earlier. If you have multiple test devices across and you're testing it in a development team and you're co-located, then it'd be better to install a shared SSL certificate on each of those machines and each of those devices, so you don't have to faff around with when you get a new device and you want to sort of connect it to Charles. You don't have to go through that, all the hoopla with setting up the SSL certificate. And that's it. I kind of I did this talk internally at Help Scout, and I've sort of just extended it a little bit, and I'm just curious to see what people think of it, whether they find it useful, if it's a tool that they would never use web proxying, and this talk hasn't changed their mind. Anything, tweet me or come and chat to me afterwards. I'm keen to hear, because if people find it useful, I might turn it into a conference CFP. So yeah, let me know. And with that, thank you very much.